Okay, so everyone can hear me?
Yes, sir.
Yeah. Okay.
Yes, sir.
Thank you.
वैसे बता देना प्रयत्न करने के लिए नहीं डोंट वरी आपका लेक्चर
Okay, session number 10 on numerical method. Now, this is a third article from the numerical that we have numerical integration. So, this is one session topic only. So today only we'll start and we'll finish it. Okay. So first we'll see the need of numerical integration. The next we'll see there are two methods to evaluate this numerical integral. Trapezoidal rule and Simpson's rule. These are the two methods that we have in our syllabus for evaluating this integration. Now, first we'll come to the need of this numerical integration. Okay, everyone knows how to evaluate the integration, but you may not know that not necessarily all the integrals that you can evaluate. Can anyone tell me what is the integration of sin x upon x? Yes. Anyone knows this? Integration of sin x upon x. Can you evaluate it? This integration. It looks very simple function. That is, one is a trigonometric, denominator is algebraic, or 1 by x into sin x is there. You may thought about by parts, but remember, it's not so simple. It's very difficult to evaluate. So many integrals are there which are difficult to evaluate, or sometimes it is impossible to evaluate. So in such a case, there is a need of the numerical integration. Okay. So main purpose of numerical integration is to evaluate those integrals where the integrands are very difficult, or this integration is very difficult to evaluate or impossible to evaluate, or you know some points only. You know some points of x1, y1, x2, y2, x and yn, and you want to integration of y with x, even though that y equal to fx is unknown to you. Okay, what I'm saying, I hope you are getting. The question, this is the question, given x1 y1 x2 y2 so on x and yn, and the question is, what is the integration of y dx from say x1 to xn? Now this is a question. You will observe we have just have n pairs of x and y. We are given n pairs of the values of x and y, and the question is integrate that y with respect to x from x1 to xn. Now already that fx is unknown to us. How we can integrate? That's not possible. So in that case also this numerical method works there. But remember, numerical methods are only applicable to the definite integral. Yes, anyone? What is a definite integral? What is the meaning of limit? Limits are given.
The limits are given.
So yes, there should be lower and upper limit there. Yeah, correct. So if the integral is a definite, then only we can apply the numerical method. Can anyone tell me what is the geometrical meaning of this definite integral? What it gives? We already seen in the last semester also. Yeah?
Area.
Yeah, very good. So that's the area under the curve. So indirectly, we have to find the area under the curve y from x1 to xn. So that is our task. And if you observe mainly, whatever the integral we are given, this integral is not, we are not able to integrate it. So we'll apply a numerical method. Now, how to apply the numerical method? So generally the method is like this. Our aim is to integrate a to b fx dx. So this is a general form of the integration. Integration a to b fx dx. What is a? A is a lower limit always. B is always an upper limit. So we should know the interval on which we are integrating that function. So in this case, a is a minus pi by 2. Minus pi by 2 means minus 3.14 upon 2, which is minus 1.57. So the value of a is a minus 1.57 and the value of b is a plus 1.57. So this is the interval on which we are integrating, minus pi by 2 to the plus pi by 2. Then in numerical integration, what we generally do, we divide this interval into the number of parts. Now we have this entire interval AB. If I want to divide it to the 5 parts, we denote it n as a 5. Okay, so this n is N depends on us, or N generally it is given in the numerical itself. So if N is a 5, how many subintervals will be there? There will be a 5 subinterval. Okay, so interval A, B, we divided into the 5 parts. So that each part is acting like a subinterval. And this each part have the class width, that interval is of this 0.628 there. How we get this 0.628? Anyone? Yes, anyone knows this? How we get 0.628?
B minus A by 2.
B minus A upon N, not 2. Okay, B minus A, actually this is a 1.57 plus 1.57, it will become upon 2. That is 1.57. If you add 2 times, it becomes 3.14. 3.14 divided by 5 is this one. So H is the class interval. So if I show you a diagram, then it becomes more clear. Let I show you here. So this is actually the graph. Whatever this curve you are observing here, this is the graph of sin x upon x. It looks little bit similar to the sine and cosine function, but it is not exactly that, because only here is a one. It is not like sine and cosine. It is not a periodic function. So forget about that, because we nothing we have to do with the graph. Nowhere you have to draw the graph. It's just for your understanding, I shown here as one example. So we are here right now. This is the minus 1.57. This point is a minus 1.57. This point is a plus 1.57. So actually this is A and this one is a B. We divided this interval AB into the 5 parts. So how many subintervals we got it here? You can check here. 1, 2, 3, 4, and 5. So there will be a 5 intervals. So N is a 5. So N parts, subinterval, that is a 5. So there are 5. So entire interval AB is divided into the 5 parts. Okay, that's one. When we divide the interval into 5 parts, how many xi values we get? Anyone? How many pair of xi and yi values will get there? So I will tell you, there will be a 6, not 5. Why? So this is like x0, y0. So this is x0 and here is y0. Okay, this is x1, y1, x2, y2, x3, y3, x4, y4, and x5, y5. But if you count it 1, 2, 3, 4, 5, 6. So we will get 6 values. Is that clear? Is that clear?
Yes, sir.
Okay. So why I'm giving a little bit stress on these notations, because in every numerical you will find these notation only. So what is happening in numerical integration? Actually, we are integrating it from x0 to xn. What is x0? X0 is A. Xn is a B. This n is a number of parts. Number of parts are 5. Number of parts are 5. And then y dx, integration y dx we are doing. So this is x0 is A, xn is B, n is a number of parts. And if you observe, the number of pairs will happen. The number of pairs will happen x0, y0, x1, y1, up to xn, yn. And how many pairs will be that? That are n plus 1 pairs, because x0, y0 is there. 1 to n is there are n pairs, and this x0, y0 is extra, that is n plus 1 pair. So that will be the general thing in each and every numerical. Now, already we've seen what we want here. We want area under this curve, area under the curve. So the first method that you are going to learn is a trapezoidal rule. So in trapezoidal rule, what we are doing, we are approximating each interval area by a trapezoid. For example, you will observe this is actually x0. This is x0. This is x1. Okay. And suppose I draw here one small straight line like this. So this is like a trapezoid. So there is another trapezoid here up to x2. Then you have here x3, the third trapezoid. So it may be like rectangle. Okay, it may look like rectangle. Then next here it is this trapezoid. Then next here is another trapezoid. So up to there is x5. So there is x4. So you'll observe that each area where remember, this is again a numerical method, gives us an approximate value of integration. It never gives us an exact value. Okay, y3, y4, and y5. Anyone knows what is the formula for area of trapezoid? Yes, what is the formula? What's the formula for area of a trapezoid? No one, huh? School days formula. Quick. Not getting any answer. Quick.
No, sir, not recollected.
No one knows. Huh?
Sum of parallel side into height.
Sum of a parallel sides into height upon 2. That's
Divided by
good. Good. Yes, partially true. Yeah. So the formula for area of trapezoid, you look on the screen now. So this is the trapezoid. I will show you the diagram. This is the diagram. You will observe these A and B are the parallel sides. So sum of a parallel side into the height of a trapezoid, that is h, upon 2. So sum of a parallel side into height upon 2. So if I apply the same, what will happen? We have to do what is the say this is the first trapezoid only. Only focus on this first trapezoid, this one. Can you tell me which are the what are the parallel sides height? What is the parallel side height?
Y0 and Y1.
Y0 and Y1, correct. So this Y0 and Y1 are the parallel sides. So Y0 plus Y1 will come. Y0 plus Y1. That is sum of parallel. What is the height of the trapezoid?
X0 minus X1.
X1 minus X0. Okay, X1 minus X0. But remember, these all X1 minus X0 or X2 minus X0, they are the H. This is the class interval. So Xi plus 1 minus Xi is always H. So this is H. So that is H. Upon 2. Now see, Y0, Y1 values are given to us, or we can compute it with the function fx, because this is our fx. Fx is sin x upon x. So if we want, we can calculate sine of minus pi by 2 divided by minus pi by 2 on a radian mode on calculator, and we get that Y0 value, Y1 value. All values we can compute. So just we have to replace Y0 plus Y1 into height upon 2. We get the area of that first rectangle. Same way, we can get the area of this second rectangle. Okay, and continue. But what happens, you will observe when you get the area of second rectangle, you get Y1 plus Y2 upon Y1 plus Y2 into H by 2. Then lastly, you get Y4 plus Y5 into H upon 2. So this H by 2 is generally taken common throughout. H by 2 is a common in every formula. And this Y0 and Y5 will occur only once. Is it? Sum of parallel sides. But remaining sum will come 2 times, because this Y0 plus Y1 is a height. Y1 is a height comes in first rectangle as well as in second rectangle. So here is Y0 plus Y1 and here is Y1 plus Y2. So Y1 plus Y1 2 times. So 2 times Y1, 2 times Y2 will come, 2 times Y3 will come, and 2 times Y4 will come. Okay. So that's one. This is H by 2 is taken outside, and this is sum of the heights of the trapezoid. This is sum of the heights of the, and that is the required area, and that is the formula. This is the formula of a trapezoidal rule. So what is the formula for trapezoidal rule? Trapezoidal rule says the area under the curve is H by 2 into sum of extreme sides. So extreme sides means Y0 and Y5. Y0 and Y5 are the extreme ordinates. Extreme ordinates. These X0 and X5 are extreme abscissa, while Y0 and Y5 are extreme ordinates. So this is we denote by X. X is a sum of extreme ordinate plus 2 times R. What is R? 2 times sum of the remaining ordinate. So this is the formula that you have to remember. Whenever we have the Xi and Yi values and we want the area under the curve, sorry, just a simple calculation we have to do. H by 2 into X plus 2R, where X is the sum of extreme ordinates while R is the sum of remaining ordinate. 2 times the remaining ordinate is there. Any doubt, anyone here? Is there any doubt? So here
No,
is
sir.
here is the answer. Good. So of the area is H by 2, X plus 2R. So the value of X, sum of 2 extreme ordinate is coming this much, sum of remaining ordinate is coming this much, and integration of sin X upon X from minus pi by 2 pi by 2 is the 2.74, 2.714. So this is an approximate value of the integration. It is a more, it is accurate. It is a more accurate. Only small error is there because when we approximate it by a trapezoid, there the upper side, this side is not necessarily a straight line, that is a curve. So there will be a small error. There's small error always in the approximation there. But to reduce the error, what should be there? Number of intervals should be large. If we go on increasing n, the error goes on reducing there. Okay, so that is the general way of the numerical integration. Now, whatever I shown here, see the examples are really simple. They're formula based. Only main part is you have to focus on the notation. Which notations will come in the numericals? Let I tell you. The first notation that will come is integration x0 to xn y dx. This is the notation will come. So already we discussed about that. X0 we have to consider as a xn we have to consider as a b. N is the number of parts there where we are dividing. Then h is the class interval. That is one more notation you have to focus. And lastly, capital X is notation we are going to use in the formula, which is the sum of extreme ordinate. So like y0 and y5, y0 plus y5, that is sum of extreme ordinate. Then R is a remaining ordinate. So whatever remaining from the extreme, whenever extreme comes, R is the sum of remaining ordinate. R always we have to consider it at the end. So we are saying it is a remaining ordinate. Then there is one more notation I am used is E in the formula. E means sum of even ordinate. So if we have y0 to y5, y0 to y5, tell me which are the even ordinate. Even ordinate means their suffix should be even. This 0, 1, 2, 3 are the suffix there. So if I say E is a sum of even ordinates, so what should be the addition?
y0 plus y2
No,
plus y4.
y0 is neither even nor odd. Remember,
y2 plus
y2,
y4.
y2 plus y4 only. Y2 plus y4 is a sum of even ordinate. O means sum of odd ordinate. So if you have to take odd, that will be y1 plus y3. y1 plus y3. y5 should not be here because y5 is already in the extreme ordinate. So extreme ordinate, whenever extreme ordinate we taken, we have to ignore that. That will not repeat again. Okay. O is a sum of odd ordinate. And last notation is there, which is say yt. Yt is a sum of ordinate whose suffix is multiple of 3. Yt is a sum of ordinate which is multiple of 3. Say y3, y6, y9, like that. We'll come to that with examples. Okay. I'll not confuse too much here because all theory I introduced mainly. Now the examples only left here. So when you see the formulas first, half of the part becomes clear. Now this is a very important slide for you where you will see the formulas. The first one is a trapezoidal rule. So you should remember formula integration x0 to xn fx dx is h by 2 into x plus 2r. X is the sum of extreme ordinate. So it is y0 plus yn. R is the sum of remaining ordinate. Suppose we have the ordinates y0 to yn. So remaining will be y1 to yn minus 1. Got it? So that is the first formula you have to remember. Next, Simpson's 1/3 rule. Now, none of the formula is with proof there. So no proof will come. You just have to remember the formula. Now, when the Simpson's 1/3 rule is preferred to use, when n is even, when the value of n is even, we generally use a Simpson's 1/3 rule. If we see the accuracy again, the accuracy of Simpson's rule is more than the trapezoidal rule. Okay. So if you want more accurate answer, better to go for a Simpson's rule. So you'll observe the formula is like this. The formula of Simpson's 1/3 rule is h by 3 x plus 2e plus 4o. This is not 40. It is a 4o. This formula or these notations, I am using this notation. If you want, you can use the textbook notations also. To remember, I use this notation actually x plus 2e plus 4o because it's very simple. E means even, o means odd, like that. So x is extreme. As usual, x is y0 plus yn always. E means y2 plus y4 plus y6 and so on. O means y1 plus y3 plus y5 plus y7 plus y9 and so on there. So that about odd. But remember, none of the ordinate will repeat there. Means if yn, suppose yn is an even ordinate, it will not come in E there. It comes only in extreme there. Okay. Last formula now, third formula, Simpson's 3/8 rule. Now when 3/8 rule is preferred, whenever n is a multiple of 3, whenever n is multiple of 3. Now, this number of parts can be like, say, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So that may be the number of parts. So whenever n is multiple of 3, means when n is 3, when n is a 6, when n is a 9, we can use a 3/8 rule. 3/8 rule can be used when n is 3, 6, 9, 12, so on. When n is a even, now when n is even means when n is a 2, 4, 6, 8, 10, then we can use a 1/3 rule. Now there is only problem with 6. Now 6 is even as well as multiple of 3. So when n is a 6, you can use 1/3 or 3/8. Both are applicable there. Is that clear?
Yes, sir.
Okay. So many of the students have the problem with 6 only. Whenever n is a 6, you remember you can apply 1/3 or 3/8 rule. And trapezoidal rule, there is no condition. You can apply trapezoidal rule for any value of n. N is even or odd or multiple of 3, doesn't matter. You can apply trapezoidal. But I will tell you in the exam, 99% numerical, the method is specified there like this. Evaluate the following integral by Simpson's 1/3 rule. Evaluate the following integral by Simpson's 3/8 rule. Evaluate by trapezoidal rule. So it is given to you, so you should not worry. But by chance, if it is not given, you should know which method you can apply it. Okay. So that about the method, and this is the formula. The formula says x is sum of extreme ordinate y0 plus yn 2 times yt. Yt is the sum of the ordinate whose suffixes are multiple of 3. Okay, sum of ordinates whose suffixes are multiple, like y3 plus y6 plus y9 and so on. And r is the sum of remaining ordinate as usual. Remaining means remaining from x and yt. Remaining from x and yt, whatever the remaining, that is r. So that about formulas. And last thing you should know to solve the numerical is this one. Area under the curve is a formula, this one. Integral y dx. When we have displacement and velocity, yes, a displacement is an integration of velocity. When we have to compute, if we have to find out the displacement, we just integrate it, integrate the velocity. And lastly, the volume of revolution formula. Okay, this is actually not in your syllabus for SEM 1. So just remember the formula. If you have to find out the volume of revolution of any curve, what is the volume of revolution? Volume of revolution is like this. Suppose we have some curve like this, y equal to fx, and you are revolving this curve about an x-axis. It gives you some volume. So the curve, this curve is rotated, then it will give you a solid like this, and we are calculating volume of that. And that can be calculated with this formula, pi y square dx. Don't go in the detail because not required. So these formulas may require in solving the example. Actually, only one example is there for volume of revolution, and one example is on velocity there, velocity displacement. That's so come to the important last part, then examples there. We'll see 2-3 examples, then it becomes more clear. It is again just a formula based. Everything is a formula based. You should know which formula you are going to use it, and you should know the notations mainly. That's all. Okay, start the first question now. The question is a curve pass through these points, and the question is find the area bounded by the curve. Now, nowhere method is mentioned. So tell me your choice, which method you are going to use it, because method is not mentioned.
Trapezium rule.
Trapezoidal rule. Okay, good. No worries, because method is not mentioned, and trapezoidal rule, there is no restriction. You can directly apply trapezoidal. That is good. But if I thought about Simpson's, which method is applicable?
1/3, sir.
1/3? 3/8 is not applicable, is that? Is the 3/8 is applicable? 3/8 is also applicable. I think you will see here. See, we always give the notation, say y0. This is y0, this is y1, this is y2, this is y3, this is y4, this is y5, this is y6. What is n here? N is 6. When n is a 6, you can apply 1/3 as well as 3/8. Any method you can apply. trapezoidal also you can apply. So you have a choice now. This example can be done by all three methods there. You will get roughly the same answer. A small error may be there because one method gives us a 7.8, other method may give 7.7 or 7.9. Got it?
Yes, sir.
Okay, so let me do this problem by trapezoidal, because someone already interested by trapezoidal. So how to do these questions? So you have to just first give the notation given say x0 is 1, xn is a 4, is it? This is x0, this is xn. I hope you are getting. What is h? Yes, anyone? What is h in this question? What is n? What is h? What is n? Quick. Don't waste the time.
N is equal to 6.
N is 4, correct. H is like 4 minus 1 upon 4. 3 by 4, I think somewhere point
75.
0.75. No, somewhere we have the mistake. Let me check. So x0 is 1, xn is a 4. N is a 4. N is not a 4. My mistake. Sorry. N is a 4. The xn is 4. That is b is a 4. But what is n? How many
Six.
parts? 1, 2, 3, 4, 6. N is a 6 there. It is not 4. N is 6 there. I hope you got it.
0.5, sir.
0.5 is h. And you will observe here also 1.5 minus 1. So difference between two successive values of x is a 0.5. This is a 0.5 there. Okay, that's one. So by trapezoidal rule, integration 1 to 4 fx dx will become, okay, fx dx will become, this is h by 2 x plus 2r. That's the formula. Now h is already, we have that 0.5 upon 2. Now tell me the x is a y0 plus y6. Y0 plus y6 plus 2 times remainings are y1 plus y2 plus y3 plus y4 plus y5. What it? Y1 to y5. And now all these values are available. Here is a y0 to y6 values are there. Just replace and do this calculation. And you check whether you are getting roughly equal to 7.8. As it is area, we're giving it as a square unit.
Sir, there are 7 readings.
Correct. Because we always have n plus 1 pair. If we have n plus 1 pair, then only we have n intervals. Huh? That only I shown on the diagram previous slide there. What if? There are 7 readings and we started the initial reading with x0, y0. Because of that, last is coming xn, yn. And that is n 6th. Okay. N is 6. It doesn't mean that we are given 6 pair. When n is a 6, we always given a 7 pair. Okay. Whenever we are given n pair, sorry, whenever we are given n pair, okay, that will confuse with n only. So when n is a 6, there will be a 7 pair simply. Got it? Is that clear?
7.775, sir.
Okay, 7.77. Nice, good. So you'll observe roughly the same answer. You got it. Okay, so whenever you write in the exam 7.77, that is also considered as correct, and they will get a full marks there. Okay, so that about the example number 1 here. If there is no doubt, can I move to the next question then?
Yes, sir.
Okay. So here is a second example. What is the best part here? The method is mentioned. Correct. So now we should not worry whether we use a 1/3, 3/8 or trapezoid. It is already said. We have to use a 1/3 rule. Okay. And we have to integrate this sin x upon x on the interval 0 to pi by 2 now. So you should tell me all these things in a notation. What is given? Yes, you can tell me one by one. Given. What is x0?
0.
What is xn?
Pi by 2.
Yes, pi by 2. Generally consider it in a radian there. Okay. You can say 1.57 also. What is it? 1.5? Yeah, 1.57. We already seen that. Okay. xn. So what is n? What is n?
4.
4. Yes, 4 parts were given. So n is 4. So if n is 4, we can find out h now. What is h? xn minus x0 upon n.
0.392.
Point
392.
392. Okay, all you can check whether it is a 0.392. Okay, good. Just a minute. Yeah. Yes. Who's giving the answer? Vaishnav, correct. 0.3925, something like that. Okay, so we got h. So what we have to do it now? The problem in this example is we have to make the table. Table is not given. Instead, we are given a function. So we can say x. Here is x. Here is a y. Just 1 minute. Eraser. This is x. This one is a y. What is y? Yes, anyone? What is the formula for y? Sin x upon x, is it? Y equal to fx there. That is integrand.
Yes,
So what is
sir.
x? x0. x0 is a 0. So first value is 0 there. So this is x0 we are writing. Actually, now tell me what is y0 then? Sin 0 upon 0. Yes. Sin 0 upon 0. Answer is 1. Why it is 1? By L'Hospital rule. Because sin 0, 0 upon 0 is indeterminate form. Or you already know the limit properties in the 12th. Limit x tends to 0, sin x upon x is always 1. Got it?
Yes,
Yeah.
sir.
So this is y0. This is y0. Now x1. What is x1 then? x1 is x0 plus h. So x0 is 0. 0 plus this, which is a 0.392 or 393 you can take. Okay, whatever you can take up to 2 decimals, so 0.39 only. But I will take 3 decimal, 0.393. So this is a x1. If this is x1, we have to calculate y1. What is y1? Y1 is sine of 0.393 divided by 0.393. But don't forget to use your calculator in a radian mode. Whenever trigonometric term appear in a numerical methods, always you have to change the mode of a calculator to the radian and do this calculation. And your y1 you will get. Yes, anyone completed? So you will get this one as a y1. Remember, already I written all these values here, y0 to y4 there. So similarly, 0.393 plus 0.393, you may get 0.7 something. Okay, so then you get y2 there. Y2 will come as a 0.9003. This is y2. Then you will get y3. Y3 you will get at 0.7842. That's a y3. And lastly, you will get a y4, 0.6366 as a y4. And what will be the x4? The value of x4 will be the xn, that is 1.57. This for 1.57 you will get. So this is this one is x0 is a 0, x1 is 0.393, x4 is 1.57. You should get this one. Is that clear? Can you make the table your own? Can you able to make this table your own? Because the table is only important.
Yes, sir.
Okay. And now remaining is just formula. What is the formula for integration now? Therefore, integration a to b fx dx is h by 3. Yes, the formula is
X plus 2E.
yes,
Plus
x plus
4O.
2e plus 4o. We'll replace this value. H is already we know 0.393. 0.393 upon 3. X is now, what is X? Y0 plus Y4, na? Sum of
Yes, sir.
extreme ordinate, Y0 and Y4. Now tell me the even ordinate. 2 times what are the even ordinate?
0.9003.
Okay, that is Y. Okay, so this is only Y2 is even. Now Y4 is also even, but it is already considered. So don't repeat the ordinate in any of the term. So if Y4 is considered in one of the term, it will not come here. So 2Y2. Now plus 4 times odd ordinates. So what are the odd ordinates?
Y1, Y3.
Y1 and Y3. Y1. And that's the formula. Now we just have to replace these values of Y0 to Y4 in this formula, do the calculation, and you should get the answer as 1.3708. 1.3708 will be the final answer there. So I will keep this as a self-study. Do this calculation later on, cross-check. You should get the answer approximately the same. Okay, approximately the same. That means 1.370678, or last decimal, fourth decimal may be changed, or that should be the same.
1.369.
1.369 is your answer? No, then
Yeah,
it is
approximately.
no. You should get first 2 decimals are really important. Yeah, first
Okay,
2
sir.
decimal at least you should have correct. Okay. Cross check then later on. Cross check later on, and if you have the still problem, you can. Okay. Can I move to the next question then? Or is there any doubt here?
No, sir, no
No
doubt.
doubt. Okay, quick. So here is a third example now. These are little standard questions which are repeatedly coming in the exam. Because of that, I'm taken here. And few examples have the little trick there that you should remember. Like this example, we are given time and velocity. Okay. The question is, this is a time is given and velocity is given. And the question is find distance. We have to find out distance from the velocity. So first, we should know the formula of distance. Distance S is integration V dt. So that is a way we have to apply numerical integration. Which method you will apply here? Again, the method name is not given, so choice is our. Okay. We can use a trapezoidal or Simpsons. Now, if we have to use a trapezoidal, should not worry. But if we have to use a Simpsons, we should check whether n is even or odd. But one most important thing is missing in the table is the velocity of a train which starts from rest is given. So this extra word indicates one pair is not given in table. So here, when time is a 0, when t is a 0, v is a 0, that is, we have to add it here. That we have to add it. Remember, by mistake, if you forget to add this term 0, 0, it will not harm that much, but the accuracy will decrease only accuracy of the final answer will decrease, because already I told if the number of pairs goes on increasing, the accuracy of the answer goes on increasing there. So when the number of pairs are very less, hardly 1 or 2 there, then obviously there will be too much error there. Got it? So you have to start with giving the notation. Say this 0 is a y0, y1, y2, y3, y4, y5, y6, y7, y8, y9, and y10. So this is y10, and this is 0 is a y0 there. So y0 to y10. Now, whenever we have last term as a y10, which methods are applicable for y10? Yn is y10 here. So which method? Simpsons. 1/3 only. Good, very good. So n is a even here. N is a 10. N is a 10. So only 1/3 we can apply, or trapezoidal we can apply. We cannot apply 3/8 here. So don't apply 3/8 rule. Only trapezoidal. And on previous example, if you get too much error, probably the answer may be given by, but it will not affect that much. You can check when n is a 6 there, n is 6, 3/8 rule may be applied there. 3/8 rule. Okay, Simpsons 3/8 also you can apply for n as 6 there. Okay, come to this question. This question becomes very straightforward now. I hope you can do it also. So that displacement S is displacement S is equal to h by 2 in bracket x. What is x? X is a y0 plus y10 plus 2 times remaining. 2 times remaining means 2 times y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7 plus y8 plus y9. That's one. That is the formula. Now all y values are available, but replace it and you will get 309.33. 309.33 will be the answer there. Got it? Any doubt there? Is there any doubt? One last question we have to see after this, but before that, I want any doubt, any problem.
So that shouldn't be y0 to y11.
No, it is y0 to y10, na, yn, na. Total 11 points will be there when we take x0, y0 added there. So points will be 11, but we started with y0 as a 0. So this last 0 become a y10 there, na? Got it?
Yes, sir.
So that is from the beginning I am telling, when we have y10 as a last value, so n will be the 10 and we have total 11 pairs. Got it?
Yes, sir.
Okay. That's one. I think that is the last question that we have. So in the first 10 session, actually, we finished now 3 important articles, roots of algebraic equation, then finite differences with interpolation, and lastly today, the numerical integration. Now only one article is left, that is a numerical solution of ordinary differential equation. That we'll see in the next class there. Okay, thank you. How many are there?